Hello everyone, welcome to the next part of our lab 1 where we are designing the sequential circuit or digital clock. In the previous lab, we discussed about how to integrate the 7-segment display, how to design a counter which increments at every 1 seconds. Then we discussed how to include the Pmod 7-segment display and display the minutes and the seconds on the Pmod 7-segment display of the Basys 3 board. Then we also discuss about how to increment the minutes counter using the push button and the switch logic. We also discuss the push button debounce. Now, in this lab, what we are going to do is that we are going to use the Pmod keypad, and by using the Pmod keypad, we are going to control the we are going to change the minutes counter. So you can see that I have connected the Pmod keypad to the Basys 3 board. Now our design is programmed. You can see that the switch is off. So whatever I am pressing on the keypad will not going to affect the minutes counter. But I have also connected the keypad output to the LED. So you can see that whichever the button I press, the corresponding digital number, binary number is displayed on the LED. So I have pressed 5, now I have pressed 8, and now I have pressed F. Okay, you can see that the corresponding number is getting displayed on the LED, but there is no change on the 7-segment display because our switch is off. Now we will make the switch is equal to 1. Now by making the switch is equal to 1, now whatever I press on the keypad, the minute counter is incremented by that number. So you can see that now I have pressed 1, now the minute counter is incremented by 1. Now I have pressed 4, now minute counter is incremented by 4. I have pressed 7, now the minute counter is incremented by 7 to 5, 12. So by using the keypad connected to the Pmod interface, we can control the minutes counter as per our requirement. So this is the lab we are going to do. So for this lab, we need to understand how this keypad works, how to receive the inputs from the keypad, and then how to connect it with our digital clock logic, which we have developed in our previous lab. For more details about the Pmod keypad, you should look for this Digilant website, where the data sheet, the interface, and the reference Verilog code is already given. Okay, so to begin with, we'll open our previous project. So we'll go to our previous project, lab 3, and we'll modify this project as per our requirement. So to begin with, I'll save this project as a new project. So this is lab 1 and part 4. Okay, so in this one, now we need to modify this code to include the corresponding keypad input. So for that, we need to go to the website and we need to download the corresponding reference code. Okay, so if you go to this website, you can see that there is a Verilog example is available. From here, you can get the corresponding code. We have also shared the Google Drive, where you can get all the source codes which are being used for this example design. Okay, so now the first thing we need to do is that for this code, we need to add the input from the keypad, and as per the reference code, this input is of the type in-out. Okay, so here this keypad input, from where we are going to receive the data, is of the type in-out. So input from Pmod keypad, which is the new thing we are going to do. So make sure that this is of the type in-out. Now, what we need to do is that using this in-out one, we will get the 8-bit input, 8-bit data, and we need to decode which of the keys is which key has been pressed on the keypad. And for that, we are going to use the reference code, which has been already provided to us. So decode keypad output. So here, let's have this module keypad decode. So for this module, if you look at the reference code, the input clock is 100 megahertz. Okay, so the inside that module, they are using the 100 megahertz clock, but the name is clock. So that's why we are connecting our 100 megahertz clock to the clock input. Then the next input is the row to decode which key in a particular row has been pressed. So for that, the MSB 4 of the MSB 4 bits are being used. So rows are connected to the MSB 4 bits of the input. Similarly, the column where the LSB 4 bits are used to detect the column, and the output of this one is the decode out, and for us we will have this output as keypad out. So this is the 4-bit because there are 16 digits on the keypad. So we have the 4-bit number, that is 3 down to 0. That is keypad. Okay, so this is the interface. Again, this is the reference code we have taken from the website. So now what we'll do is that we'll add that reference code. So we'll create a Verilog. So this is the reference code which I have copied from the website. So if you see this reference code, it has the clock input, row, column, and decode out. Clock, row, column, decode out. Okay, then clock, this is row. You can see that the column is the output. So basically what you do is that if you look at the keypad, you have the 4 rows and 4 column. So you tell the keypad that I want to read which button is pressed in this particular column. Then you get the row input from the keypad which tells that okay, this is the button in the row is particular, that button is pressed, and then you give that output to the decoder. So what you do is that you use the 1 millisecond clock to switch from one column to another column. So you can see that in the beginning you start with this particular column, then you after some time you go to the next column and so on. So for every column you check which row has been pressed, and based upon that you give out the output on the decoder. So this is a very simple code for decoding the which key has been pressed. So now we got the from the keypad that okay, this key has been pressed. Now we need to use this keypad output to update our code. So what we need to do is that based upon this keypad out, we need to increment the minutes counter. So we will have the additional input. So in the previous lab, we discussed how to increment by 1 using the switches. But if you want to increment by larger number, we can use the push button. So now you can see that I have passed the output of the keypad to my digital clock logic. Now let's go into the digital clock module. So digital clock module, we have one more input, which is 3 down to 0, and this is the keypad out. So basically we need to increment the corresponding value by the corresponding minutes value by this keypad out. Now how to develop the modify this code to incorporate this functionality. So we can go through our code. You can see that at this point we are checking whether the switch is present, and then we are incrementing based upon or decrementing based upon the push button. Now we need to add the corresponding logic. Now the simple thing I can write is that else if okay minute switch has been pressed. Okay, suppose that only the minute switch has been pressed, then I can write minute next counter is equal to current value plus the what is the input we have received is the keypad out value. So what I'm saying, if the minute switch is pressed and none of the push button has been pressed, so I can give the output of the keypad. I can increment the current minute value by the keypad, but there is some issue here. For example, we need to take care of the overflow. For example, if the minute current value is 58 and if you press the 5, then the value becomes 63. So we need to take care of that overflow. So how to take care of that overflow is that if current value of the minute plus the keypad value, if it is greater than 59, okay, then we need to make sure that we do the subtraction from 60 so that we get the correct value, so that whatever the value is above 60, we start counting from the initial value. Else this looks fine. Okay, so this is the overflow we have taken care. Now what is the issue with this is that whenever the minute switch is pressed, the input from the keypad is continuously will be added into the current pin value. And if you look at the output of the keypad, this output of the keypad, you can see that the this output is a register output. That means it remembers its value. So if we have pressed 1, you will continuously getting 1 till we modify the keypad output. So in that case, the problem is here is that the continuously, even if you press 1 and if you leave it, then and if your this switch is 1, it will continuously keep on incrementing. So we need to add the logic so that we detect that there is been new key has been pressed or the key has been pressed on the keypad. So the default code doesn't give this logic, so we need to come up with our own logic. So what we will do is that we will store the value of the keypad in the our some register. So what I'll do is that I'll create one register 3 down to 0, which is the keypad out previous. And what I'll do is that at every 1 hertz clock, okay, so we can take this code at every 1 hertz clock, this previous value, I'll make it as a current value. So this is the input coming from the keypad. I am storing it here at every 1 hertz. I'm storing. So my current value becomes the previous value, and this has the latest value from the keyboard. If both are equal, that means I don't need to increment my minutes counter. If both are not equal, that means I have pressed the new key on the keypad. So that means I need to update my minutes value. So what I'm going to do is that I am going to add the additional condition here. So this additional condition says keypad previous value is not equal to keypad current value. Okay, so if this condition is satisfied, so I have pressed that switch is equal to 1, and my current value on from coming from the keypad is not the previous value which I have just used for the incrementing. If that is true, then I'll do this increment. Okay. So these are the two conditions which are important. We need to take care of the overflow. And the second thing, we need to make sure that when we press on the keypad once, the value increment on the minutes happens only once. That we need to take care. So once this is done, I think we have done taken care of the most of the things. Okay. The next thing we need to take care is uh, we need to update our XDC file. So if you go to the XDC file, we need to update that XDC file. So what we are going to do is that in this XDC file, we are not going to use the I think we can make use of the Pmod. So we are going to use the Pmod B. Okay. So let's make use of the Pmod. In my demo video and the source code, I have used the Pmod A, but let's make use of the Pmod B here. Okay. So what we'll do is that we'll need to add this input, which is the keypad input here. Okay, so once you are done with these changes, please regenerate the bit stream and then you can test it on board. Okay, if you want to add it the LED display also, what you should do is that you can use this LED. You need only 4 bits here. So again, you need to not keypad in, it should be the keypad out. So basically you need to take this keypad out here. So I'll just add one more output here. Put 3 down to 0, keypad out, and then I'll connect it to the keypad out to the LED. So you can see whatever you have pressed on the LED, that is also visible. Okay. So these are the changes we have done. Now you can generate the bit stream and then we will see if the code works on the FPGA. Okay, so the bit stream has been generated. So I'll copy the bit stream and then we will see the live demo.